Hi guys, so today I wanted to talk about Vulkan and especially Vulkan API, and the main topic of today is how we can set up Vulkan on Android Studio and run some some project. Especially for today we are going to run a polygon one, but but for those of us who don't know, let's first of all talk about what Vulkan is. So Vulkan is a low level, low overhead cross-platform API, and it's a open standard for 3D graphics. So for those of us who are new to graphics, computer graphics, there is a library that's really dominant, and that's OpenGL. It's usually the basics for a lot of other graphics, especially graphics in JavaScript. If you ever interacted with 3JS or something, WebGL, something like that, usually they usually have OpenGL as their foundation. But why do we need Vulkan? So Vulkan is usually designed for high performance since it really integrates multi-threading to its core, and is very beneficial if you are in real-time 3D graphics such as video games, and even for parallelized programming. Is usually very it's usually very high performant in this kind of fields because the low latency, and even as you can see there is a consistent frame rate is very high. So let's go ahead and set up the project. So whenever you're setting up Vulkan on Android, and you can, there's a lot of hurdles, and usually I found this tutorial to be the best one. So the prerequisite it has is that you already have Android Studio downloaded, and you have an emulator. In my case, I'm using my physical phone as the emulator, and I have Android Studio downloaded. If you have those two steps downloaded, you're good to go. The next step is, what other things do you have to download? The other thing you have to download is these two libraries, NDK and CMake. And after you have downloaded them, you have to really include them to your environment variables. The tutorial doesn't talk about it usually doesn't talk about how you can set them as environment variables, but it's a very huge step. So for the first one, for you to download this one, you can go ahead to Android Studio, and then you will be prompted with this. If you're not aware of this file, it's just in the menu. You can go to tools, then you can go ahead to SDK manager, then here it is. You are prompted with the tools that you have. So these are my files. So you can download NDK, then the next file you want is CMake. So after that, you really have to set them so that you have them access throughout your system. You can go ahead and add them to your environment variables. So as you can see, for mine it's already set it up. One is Android Studio.zk, and Android-homes, and you just provide the path. Then you provide the path for the NDK as well, and for CMake you have to include it to the path variable. So if you can go ahead, edit, you can see in the last library we included is CMake, and the version which we have on our system. So after going all through this, the next really step is that you can clone a repository that's provided in the tutorial. So this one talks about the other stuff that's really so. Yes, the next step is you can clone this repository. It's usually a very huge file. I don't recommend it. What you can do is there is a Vulkan project that's already present in Android Studio. You can go ahead and use that one. It's really set up all of the graphics and everything, so that you can go ahead and do your work and do what's necessary for you. So to do that, you can come here and look for the new file, go to new, then you can import the sample. So usually it's just write Vulkan, and this is the file. It's a good file. It sets up everything, gives you the shaders, gives you the H file that has all the Vulkan API set up, so you can just go ahead and really interact with them. So that's for the setting up part. So you can see, you can go ahead and finish all this. Mine is already set up, that's why it's saying 2, because I already have another folder that's called that name. So the next step really is to discuss what the component of Vulkan is. So usually the main component of Vulkan is like this. First of all, we have an instance, then the physical device. The instance is just an object of Vulkan. Whenever you set up that, whenever you run the project, you have to set it up, and the main purpose is just to track the file names, the version of Vulkan you're using, the other extensions, and it usually stores those type of details, and it's integrated with the physical device. The physical drive for the system for your project can be multiple graphic card. You can have multiple graphics card access to it, and the logic, and the next one down here, the logical device is just a logical representation of the chosen physical device that you have in the system. So the physical device is integrated with families of queues to perform several different functions. So for the graphics queue, you think of sort of the graphics, the compute, it's like the analytics. The transfer is just for moving objects around, and the buffer states or something like that. Another very important thing is usually the command buffers that we are gonna interact. They're usually used for drawing, transferring cards, and something like that. And we have semaphores for the synchronization with the GPU and the CPU. We also have frame buffers, we have render paths. There are a lot of other systems. But if you follow the other step, it usually set up all the graphic pipelines, all the other certain things. So usually whenever we interact with Vulkan, these are some of the handles that we are going to be given. So we are gonna interact. These are the main handles that we interact. For the instance, you are gonna get this, the vk.instance, this is the vk for drive, this for the logical device, this for the swap chain. So sends image and sends images to a monitor, provides images to be rendered into. So all these are the handles that we are gonna interact with the APK and to the overall system. But for Android especially, there's also another one here that really shows the templates. So this is usually how Vulkan on Android works. You have the validation, which is used for development time, then you have the run, then you have the Vulkan runtime, the Vulkan drivers, then the buffer queue, and the Garok hold. So that's usually the architecture of Android. As you can see here, there's a lot of documentation you can follow up here also. So you can see the queue buffer. It gives us access to the run. It's the one that enables you to connect to the runtime through a native window. And also this one is usually optional, but you can go ahead and use it. So whenever you run the Vulkan, it gives you a sample project of a triangle, but for our case today, we are not dealing with a triangle. We are gonna deal with a polygon. And this is the setup we have to follow. So for the polygon, our color is gonna be red, and these are the dimensions for it. So these are the dimension for it. So usually we have to really transform these dimensions because Vulkan doesn't really take these huge numbers. It usually from one unit, from 0 to 1 unit on the axis, on the y-axis and the x-axis. So we have to really transform these coordinates to fit on those grid, and we're gonna go through it. So whenever you are interacting with the Vulkan, usually you have to draw things with a triangle. So there are several other things. One of the most important function is the draw function. It will help us to do a lot of things, and as you can see, this is the documentary for it. It has a parameter for the command buffer, the vertex number, the vertex count, that's the number of vertices, the instance, the first, and this is the parameter we are really gonna use today for drawing a lot of our things. Drawing the polygon, it usually identifies the vertices and everything in between. So whenever we are drawing something, we usually use lines or we use triangles, especially in Vulkan. So you have to go through it one step. So for our project now, this project for the polygon, we really have to implement it in a triangle several, so that we have a triangle like that, and we have a hexagon. We have an hexagon that gives us access to several polygons. So how we're gonna draw those hexagon is this. So we have 6 triangles. But with 12 different vertices. So we have to draw these vertices, and the fragment will color our triangle in that way. So we really have to identify what we're gonna do, how we're gonna draw this triangle. So this is the template I already set it up to answering this question. So since this is a hexagon, we can divide it into several different triangles and then draw each triangle on the same instance of an object. So how do we do that? As I talked about, this is the major thing we are gonna use seed draw or make. But another thing is to specify whether we are gonna use the type of topology we're gonna use. So the the topology is usually a function in .vk in Vulkan. So it usually helps us identify whether we want a line strip, whether we want a triangle strip, whether we want different types of things. As you can see, we have a point strip, we have a line strip, we have a triangle strip, then we have a line segments also, which is not included here. I don't know why. As you can see, for the point, it specifies a series of separate point primitive. For the line list, for the topology line list, specifies a series of separate, and this for. So usually we are gonna use this method to draw our triangle on a several instance. So if you go back to our project, we can look for that statement. As you can see, this is the one that specifies what type of things we are gonna draw. So how we gonna draw it is a totally different aspect. So whenever we specify how the type of lines we are gonna draw, whether it's a line or a triangle, then vk.draw is gonna take over from there, and so this is our vk.draw, and it has the command buffer. The vertex turn is 12 as we have indicated here. we are calling here about these vertices, these lines. As you can see, we have 1 2 3 4 5 6 7 8 9 10 11 and 12. So these are the vertices that we have to draw. Even for our shader file, these are the ones that we are going to identify. So for the vertex count, we have 12, and since this we want to be on the same diagram, we have to, our instance is gonna be 1. For the first index is gonna be 0, and this is for the vertex here, and this is for the number, the instance. So both of them will gonna be 0, since we want them to be on the same image as when we render it. And there's a lot of different graphics card method that's gonna be setting up. As you can see, this is the native file, the one that we discussed over here. Yeah, it usually helps us with the buffer queue and other sort of things, and many other different files. So we have to set up the frame rate, then we have to set up we have to swap chain support. This is for the message, the string, and the attribute. So the file is very huge, and it helps, and the template really helps us to really get going immediately and do our work from there onward. So the next big thing is how we are gonna take our shaders. So as I identified in the vk.draw, we have to really point out the coordinates that we're gonna draw. So we have 12 coordinates so far. The next one is for the colors. We have to give to all of the 12 vertices their color. So we went with red, since our question is defining red, and red in the RBJ usually is 1.000, something like that. So the other thing is how we gonna calculate our vertices. The other thing is how we gonna calculate our axis. So the way we calculate the axis is for the x-axis, we are gonna divide it by 10. So usually whenever we have Vulkan, it ranges from 0 to 1. It's a 1 by 1 grid. So you can sort of think of it as the unit cycle. So you can see here, this is a 1 to 1. So we have to map our project to on one unit. So the 1 unit is gonna be the greatest unit that we have, that we are able to present on Vulkan. So what we do for the first units, for the x-axis, is we divide by 10, and for the second one is, since the y-axis, the greatest y-axis is 12, so we set y to be 0, then step away from it. So for 0.5 we're gonna add 0.4. Then this one is farthest from the 12 as a y-axis. It's usually around 0. So as you can see in my project, I already set it to 12 to be 0.1. Then we can step ahead with 0.5 to 0.9, and then we can go ahead from there. So that's usually the main things, but as you can see, we have several. We can talk about how this graphics card really works. So whenever we draw the vk.draw, then we can get to vertex processing, dentization, then the primitive processing, racialization, fragment. So the fragment processing is usually the color. So whenever we draw a vertex from here to here, from there to there, and here to, whenever we draw a triangle strip with different vertices, the shader file immediately knows that where to color there. So the other thing that's remaining is for us to run our project. So whenever we build our project, it's gonna it usually takes a bit to really develop. So as the project continues, we can go ahead and really go through our project as well. Now it's finished building. Let's go ahead and so as you can see here, I'm using my phone as the emulator. It's really that good. You can do a lot of things here. So as you can see, this is the project well built up. So we can take a screenshot of it. So that's for the whole tutorial. Thanks for watching.